So we're on example B on page 3 of the white packet for Unit 9. It's on sigma notation. And many times we'll look at one of these problems and we'll say, oh, good, this is one. They want us to find the sum, so I'm going to use this formula. And here's another version of the formula. Did we talk about it yesterday? Times the number of terms and then all divided by 2. Okay. The other way that we just talked about was U1 plus UN. You can use U's or A's. Doesn't matter, really. Times the number of terms over 2. Either way, that formula usually helps you find the answer. Why won't it here? What does this little A stand for? Arithmetic. And when you see this formula, that is not arithmetic. It contains an exponent, making it geometric. All right? What we learned about way back in Unit 1 was that this was what? Arithmetic. And it was closely related to what we learned in Unit 2, which was what? Linear, okay? The sequences that we made that were in a straight line, if you graph them, were called linear. And we came up with these linear equations. The other one we learned about was called geometric. And instead of starting with U0 and adding the common difference, it multiplied by the common ratio n times. So n was the exponent. So when you see a formula like this, you may not use these. All right? We related it in Unit 5 to y equals ab to the x, which were exponential functions. So that's basically a snapshot of semester 1 in this class. In addition to those things, we did some transformations of all the functions, and that was about it. So now we move on and we think, well, what am I going to do then if I can't use the formula? If I can't use one of these formulas over here, which you cannot, you have to use an alternative method. And for now, it's find all the terms, add them up. All right? So what I'm going to show you today is just another way of organizing those terms. And it's just a table of values. All I'm going to do is make a column for n and a column for the formula from the sigma. I just put this here. The n values are going to come from what I see here and here. They tell me to start with what? And proceed until I get to what? So these numbers come from the sigma on the left side. On the right side, you're going to get the answers by plugging in 1, 2, 3, 4, and 5. So plug in 1, see what you get, put the answer here. Plug in 2, calculate it, see what you get here. Plug in 3, calculate it, list it. Once we list all of these terms, what does this mean to do with them? Add them together. Here, I'll show you. For the first one, you should get 4. And the reason I get 4 is, when I plug in 1, it's 4 times 0.8 to the 1 minus 1, right? Exponents first. What's 1 minus 1? 0. Apply that exponent. What's anything to the 0? 1. What's 4 times 1? 4. So that's where I got this answer. Good. So for the next one, you should get 3.2. And I'll show you why here. It's 4 times 0.8. What are we plugging in for n? 2. minus 1. What is 2 minus 1? 1. What's 4 times 0.8? 3.2. So that's where I'm getting these answers. You can continue that process. How many more times? 3 more times to get n equals 3, n equals 4, and n equals 5. Okay, there are the 3 answers that you get when you put in 3, 4, and 5. And the sigma means to add all these results. Add all these numbers up, and what do you get? 13 point, I think it's like, yeah, 4464, I think I remember. So there's your sum. All right, so that's, for now, how we're going to do the non-arithmetic series.